I'm going to go pretty fast, so if you need to go back over these notes a couple times, please do so. We're going to be finding the answer to a system of equation, which means just the point they have in common. So it's most often 1 point, but every once in a while it's no points or a bunch of points. So we're going to really need to be thinking back to what we learned early in the year about y equals mx plus b, where that number in front of the x is the rise over the run, and that number at the end, the constant, is the y-intercept. So here's one already done for us, and we have it in slope-intercept form. And this line right here has a slope of 2 and a y-intercept of 2. So that's this line right here. And then this line right here has a slope of a -1 and a y-intercept of 2. So this is the orange line, and this is the blue line. So the point they have in the common is right there, and it's defined as over 0 up 2. And you're going to be doing that on your own. Let's talk a little bit about what can happen when you graph two lines. Most of the time there's 1 point in common. Again, that point is 2 different lines, but it happens to be the same common point, over 0 up 2. But you can have the special situations of them having no points in common because the two lines have the same slope or same pitch and they'll never intersect. Or the two lines could be on top of each other, which means they have an infinite number of pairs in common. They're on top of each other, so millions of ordered pairs they have in common. Please notice that we want an x and a y quantity for whatever they have in common. Most of the problems that you'll be having today are set up for you in slope-intercept form. So of this problem, the slope is 1 and the y-intercept is 6. And it's a little hard for me to do this with one hand holding the camera. And I think our intersection's off the page, so I need to continue it off a little bit. So there it is. It needs to be pretty straight because of the fact that you're finding a point they have in common. And then this one right here has a slope of 2 and a y-intercept of 2. So it's going to start at 2 and it's going to go up 2 over 1, up 2 over 1, up 2 over 1, and up 2 over 1. So there's finally the point they have in common, and my line doesn't look very straight, but I can estimate that it's at 4, and this would be 9, so this would be 10. So their point of intersection is right there, over 4 for the x and up 10 for the y. When we plug those in, they should work in both equations. When I plug in 4, I should get out 10. 4 plus 6 is 10. 2 times 4 is 8. 8 plus 2 is 10. So that's the point that works on both of these. When you plug it in, it makes a true statement. A couple of them will get a little harder because you'll have to solve for y first. So when you solve for y, you will get this. You're going to subtract the x from both sides of the equation, and when it goes to the opposite side, it's going to have the opposite sign. So I'm going to start at 5, and I'm going to go down 1 each time. Or the reverse would be back 1. So that's kind of the tilt of this first line. The second line, I'm going to subtract that 2x from both sides. Opposite sign, it takes on the opposite sign. And it's going to cross at 1. And it's going down 2, but that's not going to have them intersect if I go down 2. So let me go the opposite direction. And it looks like they're going to intersect right there. So here's my two lines, and the point they intersected at is that one right there, which the x value is -4 and the y value is 9. This is your homework assignment here. Remember that this could be written as y equals 0x minus 3. You guys always struggle a little bit on the horizontal and verticals. So this one's going to start at -3 on the y-axis and have a slope of 0. So think about whether that would be horizontal or vertical. This one can't be written in slope-intercept form, which means it has no slope and no y-intercept. So what would that mean? Is it horizontal or vertical if it has no slope and no y-intercept? So this is one of those where you're going to have to solve for y. These two, you're going to have to solve for y as well. So you might want to do that on a piece of scratch paper.